rightly said, mathematics is the most beautiful and the most powerful creation of the mankind. And this is the series where we will be exploring how our ancient Indian mathematician contributed towards making mathematics so powerful we see today, with a flavor of programming over it. Because to be a good programmer, you need to understand the basic principles of programming. And to understand the principles of programming, you need to understand abstraction. To understand abstraction, you need to understand mathematics on which it's based. So, in this video, we are going to learn how to convert Acharya Aryabhat's root extraction method into a C program. So this video is divided into two parts. In the very first part, we are going to look after the method itself. We will understand how the method works, and in the next video, we will be understanding the coding part. In this video, we are discussing about the father of Indian mathematics, Acharya Aryabhat, whose name literally means the warrior of nobles. Nalanda University was one of the world's first educational institution established in the 5th century, and Aryabhat was the head of this university. And when in 1975 government launched its first satellite, it was named after Acharya Aryabhat to honor him. If you are an experienced C programmer or you have done a very good amount of problem solving in it, you must have surely come across these summation problems. So, do you know that these formulas were discovered back in 5th century, and these formulas have their mention in Aryabhat's book Aryabhatya, which was written in 5th century, and these summation formulas were known to be Sankalita and Varsankalita. So let us have a look over one of the most famous work of Acharya Aryabhat, that is Aryabhatiam. So in this book is divided into four parts. Let us talk about Gitikapad. So this talks about cosmology, planetary revolutions, and Ganita Pad talks about mensurations, progression like APGP, and then equations chapter deals with quadratic equation, indeterminate equation, and the algorithms given to solve these indeterminate equations have great importance in computational sciences. So if you want to have a look over the computational aspects of these Aryabhat algorithm, you can refer to the uh, article by S. Kak, known as Computational Aspects of Aryabhat Algorithm. The link will be given into the description box. And next part is Kal Kriya Pad. So this uh, pad or part talks about the determining the position of planets. It talks about different units of time, and then Golpad, which talks about celestial sphere, shape of earth, cause of day. So now let us move on to square root extraction method, which is taken from Ganitapad verse 4. Bhagam haridvarganityam द्विगुणेन वर्गमूलेन वर्गद्वर्गे सुधे लब्धम स्थानांतरे मूलम. So now let us understand the meaning of shloka by actually performing the steps. So first unit place is always considered odd, and mark the places, alternate places, odd and even. Here the circular dot is odd and that dash is even. So this is the step 1 to do, very simple. So now locate the last dot place, that is the second a digit from the left and find the number that holds the position. So here the position holding is done by 11. And then next, so now let us move on to step 3, where we have to find the nearest square to 11, such that 11 minus that square should be minimum. And let us understand by example. If we subtract 11 from 1, we get 10. And when we subtract 11 from 2 square, we get 7. But when we subtract 11 from 3 square, we get 2. But after that, when we move on to 4 square, 5 square, we start getting negative value. We don't need the negative value part, so we will take the nearest square to be of 3. Now we have found out the nearest lesser square, that is 9, and we will subtract it from 11, and we will put its square root, that is 3, aside as the most significant digit of this final square root. Next, we will locate next place to the right and move the digit down next to the result of the previous subtraction, that is 2, to form 29. Since we are in the even place, we divide 29 by the twice the current root, that is 3, and then we put its quotient, that is 4, to the right of the current root as the second digit. Now we multiply 4 with 2 and the current root, that is 3, which gives us 24, and we subtract this 24 from 29 to get 5. Now we move the next digit to the 9 to the result of the previous subtraction to form 54. Since we are at the odd place, we take the previous quotient and subtract the square of it from 54, and that will be 16. 54 minus 16 is 38. Now we repeat steps 4 to 5 till we don't reach the first odd place. Now by repeating these steps, we will finally reach the final answer, that is root result 3456. So how accurate this method is. This predicts how powerful our ancient Indian mathematics was. This method was discovered back in 5th century, and at that time there was no internet, no YouTube. Today we don't understand anything, we just head on to YouTube and we understand it. But at that time there was no such facilities, no calculators. But still, you can see the beauty of the method, how accurate it is. So with this we end the first part of this video, and next part we will be looking after the code explanation, and there you will get a better understanding of this method as we will be looking upon the method more closely. So thank you for watching.